Welcome to TMT. This is Kuldeep Kandwal from Department of Mathematics, Thakur College. So, in mathematics, I am going to start the topic which is named as logic. Hope you are aware about this topic logic number of times, even that all people says this word logic here. The question is that what is the logic actually? So, what is logic? So, remember that logic is the science of reasoning. Logic is science of reasoning. What a logic you apply, we check that what reason is there. Even that you must have listened so many jokes and you laugh, sometimes you don't laugh. And when you laugh, actually you laugh on the logic applied by that particular person. So hope this is very clear that what is the meaning of logic here. Another thing which we will discuss here, when we talk about statement. Again, it's not a English grammar lecture actually, but before that, we should know the meaning of sentences. Again, normally you know that there are different types of sentences, interrogative sentences, affirmative, imperative, and so on. But for statement, the exact definition is, for the statement, it should be any declarative sentence which is either true or false. So let me remember this one, true or false, but not both at the same time, is called logic. So the definition of logic is very clear. It should be declarative sentences. Remember that which types of sentences we do not use. We cannot use here interrogative sentences, interrogative, imperative actually, command, exclamation type of that. These types of sentences are not statements. These are not the statements. It should be declarative. Remember that whatever sentence you find, if you find it is a declarative and we can find its truth value, it could be true, it could be false, but remember that it should not be both at the same time. Then you can claim it's a logic. For example, if I say, I am telling for myself actually, I am Prime Minister of India. Remember that, you know that it's false, no doubt. Everyone will say false. Maybe statement could be funny. Again I say, for that one, statement could be funny, but we should know whether it is true or false. So therefore, I am Prime Minister of India is a statement. I am writing here statement. And what is the truth value here? False. Maybe in most of the time after that, I will represent false by F and true by T. So you can see that part. The true and false should be there. So now some of the things I am writing here, and I am forcing you to think whether it's a statement or not. If I say x plus 2 equal to 7, is it a statement? I have declared it. X plus 2 equal to 7 is a statement which I have declared here. So most of the students may think that it's a statement, we say x equal to 5 and so on. Remember that it's not a statement. It's an equation. It's an equation, or we can say open sentences here, because I cannot decide whether it is true or false unless and until I know the value of x. And if I say x plus 2 equal to 7 and x equal to 8, then it's a statement, because now any student, any person can verify, and definitely it is false. If you go for this one, x plus 2 equal to 7 and x equal to 5, this is a statement, but truth value is true. So when you get confused that it could be true or maybe false, definitely it's not a statement. We cannot take the middle value. So now another part which I want to discuss with you. So if I say 5 upon 5, you will say 1. 10 upon 10, 1, minus 200 divided by minus 200 equal to 1, and so on. It means what I am doing here, that any number divided by itself, answer is 1. So therefore, if I write a conclusion from this one, that when any number is divided by itself, you can see that answer is 1. Answer is always 1. Now this is my statement. Is it true or false? So what I did here, that some numbers I have written here, you can see that, and I have divided those numbers by their self, and I am getting the answer 1. So when any number is divided by itself, answer is 1. Is it a statement? So remember that this is false. And the question arises, why? Remember, 0 upon 0 is not defined. So therefore, this statement is not valid for 0. Any number, when it is divided by itself, clearly you say answer is 1. And when we go for 0, this condition is not satisfied. Similarly, some other things let me discuss with you. And if I say 5 square, you say 25, minus 3 the square plus 9, 8 square 64. Therefore, when we see this one, this is 64 here, and minus of 7, we get here 49. So from here, if I say that square of any real number, you must have seen that in your 9th and standard, is always positive. So what I have written here? So I have given some examples, and definitely all are true. And from these things, can I draw this conclusion that square of any real number is always positive? Again, remember that this answer is false. Don't claim this one, because 0 square equal to 0, and 0 is not positive. So these are some of the things which I have written here. Again, I tell you, better I tell a simple story about logic here. Whenever we say logic here, see, hope you are aware about that layman, logician, and a mathematician. See that 3 persons are there. Assume that whatever I am telling, assume that it is true, that, and they find first time in coming to Mumbai. These 3 people, one is layman, other is a logician, third is a mathematician, maybe a fast friend, first time coming to Mumbai, and they find a pink dog in Mumbai. Pink dog they find. So definitely they have observed it, and let us see that what they say, what are their statements. So one by one I am writing here. So the layman says, dogs in Mumbai are pink. Nothing wrong with that one, right? A layman person has given this statement, but if the person is logician, let us see that what a logician says. A logician says that some dogs in Mumbai are pink. Again, logician is much accurate than a layman. But remember, a mathematician should be much more than a logician. Whatever a mathematician says, there should not be any contradiction. Once a contradiction is occurring, it means whatever statement is there cannot be trusted. We cannot call that a statement. So let us see that what the mathematician is telling. And the mathematician says, there exists at least one dog. There exists at least one dog in Mumbai who is pink. So now you can see that from that logic, a mathematician which I have applied, no contradiction here, right? A mathematician cannot say all, cannot say some, because one they have seen, so at least one is there. So this concept of a mathematician for logic, I think this is very clear to you. Remember that if I write some of the sentences, and you have to claim whether it's statement or not, these things we have to see here, right? At the same time, some example I gave you, that x upon x is how much. One very popular formula, everyone of you know that, especially if you had maths in your 9th or 10th level, equal to 1. Cos square theta plus sin square theta equal to 1. Everyone knows that. It is. But remember that this is not true. First thing is that theta is not defined. Again, if I say theta is defined, then what? If I say if theta is real, no doubt theta is an angle, then above result is true. Then above statement is true. Okay, so now I have explained to you what is the sentence, what is the statement, and for logic we are worried about statement actually, because we have to decide whether it is true or false, right? But not both. My question is that as today is Tuesday. Today is Tuesday, and because this recording is going on Tuesday, so I have written here Tuesday. So definitely it's a declaration, and what you will say, what is the truth value? Everyone will say true, or we can say T also, capital T also, true. And suppose this question is asked in exam, and examiners on Tuesday, they will say that this is a statement, truth value is true. And deliberately, I will correct your paper on Friday. I will see this one on Friday. And then on that day, today is, if I go for Friday, let me remove this part. This is Friday here. If I correct that one, on that day, this statement is what? Definitely on Friday, it is false. So, again, I say today is Tuesday, and suppose today is Tuesday and it is true. This statement has truth value true. Deliberately, if I show this statement on Friday, then definitely this statement is false. So how many truth value we got here? We are getting two truth value. One is true, other is false. So my question is that, is it a statement? Because clearly I told you, either it should be true or false, not both. And here I have shown that this statement is giving us two different truth values. Majority of learners may say that it's not a statement. Remember that it's still a statement. The reason is that the definition which I gave, true or false, at the same time. Remember that at the same time, something changes with time. If I say it is not raining, it is definitely true. But maybe when you read this statement and at that time raining, you will say false. So you cannot claim that that statement was false. Because time changes, value changes. So truth value gets changes, that's not an issue. Another thing we come that is very popular for a statement, that is negation. So if I say Mumbai is in Gujarat, definitely it's a statement, it's a false, right? No one can object here. Mumbai is in Gujarat, and this is a statement definitely, and truth value is false. False I am writing here. Now that, what about the negation of this? Suppose this is P. I have given name to this statement as P and negation of P. See the symbol, this one, symbol of negation. So negation doesn't mean correction. That you cannot say that Mumbai is in Maharashtra. For negation, that logic says you only write Mumbai is not in Gujarat. And definitely true. So remember that when any statement is true, if statement is true, its negation must be false. Must be false, and vice versa. That maybe the statement is false, that its negation should be true. So remember that we do not use opposite word here. If I say that 2 plus 5 is greater than 15, so definitely I have declared it. You can verify. And what about the negation? Suppose the name of this is Q and I want negation of this Q. We will not correct it. Negation doesn't mean correction. So So don't say that 2 plus 5 equal to 7. No. For the negation, you will say that 2 plus 5 is not greater than 7. So not greater than means it may be less than or equal to, see that the symbol. This is the correct way. If I say that this is false, automatically this will be true. Right? So Q and negation of Q, two things are there. So when we write negation of any statement, we have to write in that format. If I say Ravi is honest, and suppose the name of this statement is R, so negation of R will be Ravi is not honest. Some of the time we can use opposite word here for this case, because not honest means dishonest also, but avoid using opposite word. Avoid using opposite word for negation. And remember that if one thing, any statement is true, negation must be false here. Now one thing I am writing here, and let me see that what you think about this one. If I say one statement I have given, let me write this, give name statement as R, and R is some students are naughty. No doubt, this is very good. Everyone will say that it's a statement. I am not asking that whether a statement or not, because I have declared it, it's a statement, no doubt. And definitely it is true. And my question is that, what about negation of R? And negation of R, when we say, if you say that some students are not naughty, remember that that's also true. Even that if I say some students are not naughty, that's also true. So we cannot claim that this is the negation of that given statement. So logic says that if any statement is true, its negation must be false. So what we have to write? So it is clearly defined in logic that negation of R will be always some should be replaced by no. So the negation of this statement will be no student is naughty. Now you can see that this is automatically false. So while writing negation, simply using the word not is not sufficient. You have to see that what it is mentioned here. Even that one statement if I write here, and that is suppose S here, if I say all politicians are corrupt, remember this is false, right? We cannot blame all. If you find some examples, and from those examples you cannot generalize your statement to the all. As a teacher, sometimes we use this wrong thing. Maybe 2 or 3 students have disturbed the class and we blame entire class. It happens, right? So therefore, if I say all politicians are corrupt, no doubt it's a statement which I told and it is false here. So then what is the negation? Negation of S. And negation, that all negation should be replaced by there exists at least one politician who is not corrupt. That is correct. Just like that, if I blame entire class for anything and one of the students says that I am not according to that what you say, so at least one has opposed that, so definitely my statement is not valid, therefore maybe false, right? So one thing I am telling that the logic I have explained that a statement is there. A statement should be either true or false, but not both at the same time. So one famous thing is I am writing here, and I am a liar. Is it a statement? I have declared I am a liar, and the question is that is it a statement? And if it is a statement, so remember that either it should be true or false, but not both. Remember, this is a paradox, and paradox means self-contradictory. If I assume that I am a liar, I will prove that I am not a liar. And then secondly, I will say that no, I am not a liar, and from that I will prove that I am a liar. So the statement which contradicts itself are called paradox. So we cannot decide whether true or false. So definitely not a statement. Let us see that two cases can arrive here. Maybe first let above statement is true. And if above statement is true, then definitely this implies I am a liar. I am a liar. Right? And you know, what you're a liar says that, we can say this implies that truth value of a liar is always false. And because I am a liar, therefore my statement that I am a liar is false. And this implies that I am not a liar. See that. What I have assumed that? I assumed when this statement was true, it was true. I claim that I am a liar. This statement, you can see that. Immediately after that last line, we check that. What I have proved that I am not a liar. So I cannot decide that we are getting two truth value at the same time. In a same tone, when I say that I am not a liar, suppose this statement is true, then this is the condition. I am a liar. I have shown that I am not a liar. It's a paradox. Remember that. If I say, let I am a liar is false. And if it is false, definitely that implies that I am not a liar. And if I am not a liar, that the truth value, whatever I say, has truth value true. Therefore, what thing I told, therefore, I am a liar is true. See that. What had happened here? I assumed that I am not a liar, and from that I have shown that I am not a liar. So I am a liar is not a statement. No doubt it's a declarative, but we are getting two truth value, and we can say is a paradox. We call them as paradox. And paradoxes are always self-contradictory. Such thing cannot be claimed as a statement. Even that one Barber paradox is also there. So many paradoxes there. So that will go discuss on. So I think you have enjoyed this lecture. Thank you very much. We'll see you for the another part of the logic and other thing. Have a nice time.